one nice thing about this topic is it will simply tell you to do it. It'll be written into the question, use Euler's method. So there's no problem solving. It's the same every time. We're going to have a formula for the gradient, and they'll give us a starting point and a step, and then I'll ask you to find an estimate for something. So in this case, the question says, starting at 1, 1, going on along in steps of 0.1 on the x-axis, what is an estimate for the y value when x equals 2? So let's just visualize that. Here is the slope field for dy by dx equals x plus y. It's telling us the gradient for every possible coordinate. So for example, 2, 3, what's the gradient there? Well, we have a formula for that. 2, 3, put it into here, it's 5. The gradient is 5, and we can see in this region we've got very steep positive gradients. Now this question says there's a starting point, 1, 1. There it is. So we start there, and Euler's method, by going along 0.1 and then going up, 0.1 going up, it tries to follow this green line until after 10 iterations, we're going to come to a value that looks like a tiny bit more than 5. That's what we should get. But Euler's method will go across 0.1 and then move up in a straight line, so it's not on a pure curve. We go to the formula book, and there is the formula for Euler's method. The oddity is that this notation here, f of x, y, that just means the gradient. So it's the only formula in the question, x plus y. It's a bit odd to call it f when it's a gradient, but that's what it says. So just remember, that's the only formula in the question. So I'm going to put an x plus y in there. H is given as 0.1. The starting value x naught, y naught is given. And we interpret this to say, well, if we're going from 1 to 2 in steps of 0.1, then I need 10 steps. Everything is ready now for the calculator. So we go to menu and go down to recursion. And often it's already half typed in from the previous time. Mine is. And so, in fact, I've already got this one because this x1 never changes. Slightly annoying that the calculator uses a's and b's instead of x and y's, but obviously that's easy to change in your head. So this one already says xn plus 1 equals xn plus 0.1. Perfect. Let's go down to this one. Bn plus 1 equals bn plus 0.1 times, and now I will have to change this. In fact, mine's already quite similar. I just have to type x plus y in here. And we see we have these on the screen here. I just need to delete that. Perfect. So it's all set up. You then click on set to set the starting conditions. This is just like how many iterations. We always want to start on 0. Let's have 10 iterations. And my starting point is 1, 1, given in the question. So 1, 1 is there. So then I can now just have a look at the table. And you should draw on your exam script a few of these, maybe the first 3 and the last 1 or 2. So there it is. The x value is going up in 0.1s. That's because we're just adding 0.1 to it each time here. And then the y value is creeping up, and we get this estimate, 4.78. So I would write enough down on the script to get the marks for it. So easy. Let's have a look at that 4.78. If I go to here, 4.78 is not amazing as an estimate. And that is because it's turned this curve into a series of 10 little straight line segments. And each one of those has a slight error in it. So the more segments you have in Euler, the worse the estimate. Okay, that's it.